All right, welcome to video number 5. Before we get the warm-up problem going, probably noticed something a little different. I did get a haircut after videotaping those first few. I watched them and realized I really needed a haircut, so I went and did that yesterday. I also grew giant hands so I can palm this full-size basketball. Hopefully it looks like a full-size basketball on there. But anyway, we've got a warm-up problem here that asks us to find the roots of an equation, y equals x squared minus 4x. Roots, remember, is another word for solutions. It's another word for zeros. It's another word for x-intercepts. When we're solving for x, these are all mean the same thing. So I'd like you to try that problem now on your own. Okay, hopefully you've tried that and got an answer. We know we find roots or x-intercepts by making y 0. And what we looked at in our last video and in class yesterday were problems like this where there's a common factor that we can take out and make our factoring easier. Both of these terms have an x in them. We can take that x out. We can factor out the common factor of x and leave us with an x minus 4 inside here. And then remember that x counts as its own factor when we go to solve. So we have to set that x equal to 0 to create one of our roots or solutions, and the same thing with our x minus 4. So we'll find that our roots are 0 and 4, and again, when we go to graph something like this, these are the places where our graph would cross the x-axis. All right, so hopefully you know how to do that. What we'll look at today is a special kind of quadratic, something called a difference of squares, and we'll talk about where that name comes from. This question says, what are the factors of x squared minus 4? Notice this isn't an equation. We're not actually being asked to solve anything here. We're just given an expression, no equal sign. So we're being asked to break down x squared minus 4 into the two factors. So, thinking about having parentheses and breaking that down. Now what you'll notice is that there's something missing in this problem that we usually see. We're missing, we call that linear term. In the middle, there's usually a term that just has an x. Here we've got our x squared term out front. We've got our minus 4, our c value, that constant that always shows up at the end. But we're missing something in the middle. Now, at first, it might help you recognize this by putting like a 0x in there. If you'd rather see this as x squared plus 0x minus 4, and that looks a little bit more normal to you. But let's think about how we would factor that. Let's think about the process of breaking that down. We still have that x squared out front, so we would expect there to be an x times an x. Remembering what we know about our signs, since we have a minus 4 as our last sign, that tells me these signs will be different. So I've got a plus and I've got a minus here. Then let's stop and think about, well, what would have happened to make that middle term go away? Why is there no x term in the middle? Well, if I think about where that x term, where that middle term comes from, it's when I FOIL, when I do my outer and my inner, when I distribute those terms out. If I combine those, for some reason, we're not getting any value. That's because those terms are canceling out. So as I go to try to break this down into the factors, I want to think about what could I put here and here that when I do my outer and my inner and combine those, that term would go away. And what would make that happen is to make those two numbers the same. I need something times something to equal 4, and if I want those to be the same, 2 times 2 would work. And by doing that, now I think about my outer and my inner terms, x times a negative 2, and then a positive 2 times x. Negative 2x plus 2x, those terms would add out. They would cancel out, we'd be left with no x's, and that term would be missing. So when we break that down, it breaks down into the factors of x plus 2 and x minus 2. Right? And in general, you're going to see that pattern as we have x squared minus, a number that we call a perfect square. Something we can multiply a number by itself to get this number. 2 times 2 is 4, and so that 2 times 2 goes there to help us factor this down. Now, let me take this same expression, this x squared minus 4, and let's talk about how we would solve an equation that had an x squared minus 4. And here you actually have a couple of different options. If we wanted to solve x squared minus 4 equals 0, we can do factoring like we've been doing. And that's strategy 1 over here. We could break this down into our factors that we just found. X times x, signs were different, 2 times 2 to give you 4. and then set those factors equal to 0 and solve. So that's the more normal way, I guess, to solve this that you're used to because we've been doing the factoring. But in this case, it's a little bit of a special case. We can go back and find this solution for x here just by getting x by itself, what we call isolating the variable. Like we used to do when we just had linear equations. We just had a straight line equation. Because x only shows up in one spot here. Normally, the x shows up in two spots. We have an x squared, and we have that x term in the middle. That's not in this problem, so another way we can handle this problem is just getting x by itself. Adding 4 to both sides. Give me x squared equals 4. If I think about, well, what do I need to do to get from x squared back to x? Well, I need to get rid of that square, and the inverse, the opposite of squaring something, is taking the square root. So I can take the square root of both sides here and figure out a value for x. Now, if you're going to use this strategy, it's important to remember that not only is 2 squared 4, but also negative 2 squared is 4. If you put negative 2 in your calculator, assuming you remember to put it in parentheses like we've talked about approximately 11 billion times by this point, if you do negative 2 squared, you're going to get a positive 4. So negative 2 should be another solution to this equation. We know that from over here also. So it's important to remember, if you're going to take a square root when you solve an equation, you're going to have both a positive and a negative answer. We put that plus or minus sign there to indicate that. So our answers are positive 2 or negative 2. You can write them separately if you want. You can just say x equals 2 or x equals negative 2. But it's important to remember that we've got 2 solutions there when we take our square root. So 2 different ways you can solve this problem. Factoring like we're used to and setting factors equal to 0, or simply getting x by itself. All right? So I've left you with a couple to try here. A factoring problem and then solving that same problem. So you go ahead and try those now. This is the same form as we saw with the previous problem. What we call a difference of squares, because we're subtracting 2 things that are squares. X squared, obviously, but 25 is 5 squared. And in general, the way that we factor things like that, since we've got that missing term in the middle, is to make sure that these 2 numbers are the same so that that outer and inner term would combine to cancel out and just leave us with x squared minus a 25. So that's how you would factor that. And in general, it's always going to be x plus that number and x minus that number. Whatever number you can multiply by itself to get 25, the square root of 25. All right? Then solving that equation, you had a couple different ways maybe you solved that. If you use the factors you did in question 1 to solve, then you set those 2 factors equal to 0, as we've done so many times. You get that x could be negative 5, or x could be positive 5. We get our 2 solutions that way. The other way you could do this, just getting the x by itself. Again, we haven't talked about this way to solve the other quadratics because the other quadratics had the x in 2 places. We couldn't just get x by itself. We couldn't combine those 2 terms. Here, since x is only in one place, we could add 25 to both sides. Get x squared is 25. And then we take our square root. Don't forget, when we take our square root, we need a plus or minus there for our 2 separate solutions. All right, so the positive square root of 25, positive 5, and negative square root of 25, negative 5 are our 2 solutions there. Notice, exact same solutions either way. Right? And if we were to graph y equals this, we were to graph this parabola, this U-shaped graph, that graph would cross the x-axis at negative 5 and at positive 5. All right? So that's one more technique for us to factor and solve quadratics. We'll try some of those problems in class tomorrow.